RFID card reader, a radio frequency identification reader, or RFID reader, is a device used to gather information from a RFID tag, which is used to track individual object. Radio waves are used to transfer data from the tag to a reader. The RFID tag must be within the range of an RFID reader, which ranges from 3 to 30 mm, in order to be read. RFID technology may be used in a variety of applications like passport, smart card, airplane luggage, toll booth passes, animal and pet tags, etc. In this video, we will learn how to read a RFID card using RFID reader RC522 and Arduino Uno. Here is the connection diagram of this project. RC522 has 8 main pins: VCC, ground, RST, IRQ, MISO, MOSI, SCK, and SDA. SDA pin is also called SS. VCC pin is connected with the 3.3 volt pin, and ground pin is connected with the ground pin of Arduino. RST pin is connected with pin number 9 of Arduino. MISO pin is connected with pin number 12 of Arduino. MOSI pin is connected with pin number 11 of Arduino. SCK pin is connected with pin number 13 of Arduino. SDA pin is connected with pin number 10 of Arduino. IRQ pin is not used. 16x2 LCD display has 2 lines. Each line can display 16 characters. This display has 16 pins. First pin is ground, second is VCC, then contrast, RS, RW, enable, D0, D1, D2, D3, D4, D5, D6, D7, VCC, and ground. Pin 1 and 2 provide the supply for its internal circuitry, and pin 15 and 16 provides the supply for its backlight. We have connected pin number 1, 5, and 16 with the ground pin of Arduino, and pin number 2 and 15 with the 5 volt. Pin number 4 of LCD is connected to the pin number 7 of Arduino. Pin number 6 of LCD is connected to the pin number 6 of Arduino. Pin 7, 8, 9, and 10 are not used. Pin 11, 12, 13, and 14 of LCD display are connected to the pin 5, 4, 3 and 2 of Arduino respectively. This is the code of this project. To control the LCD display, we will first include its library in the program. To include the library, we will write in the first line, #include liquid crystal.h. Then we will declare the name of the used pins, in the sequence of RS, enable, D4, D5, D6, and D7. RFID reader RC522 works on SPI protocol. To use the SPI protocol in Arduino, we will include its library. To include the library, we will write #include spi.h. To use RFID reader RC522, we will include its library #include mfrc522.h. SS pin is connected with pin number 10 of Arduino. RST pin is connected with pin number 9 of Arduino. Void setup is a function in which we have initialized the LCD. LCD.begin 16,2. It means we are using 16 columns and 2 rows of the LCD display. SPI.begin is used to initialize the SPI protocol. mfrc522.pcdinit is used to initialize the function, which will read the RFID tag. Void loop. This function will run over and over again, so whatever we write inside, it will repeat forever. This function will wait for a card to be punched. This function will read the ID of card. This function will print the ID of card on the LCD screen. Now, we will write a code on this software. After writing the code, we will save our project. Now we will compile our code. For doing this, press this check button. If there is any error in the code, or the code is incorrect, it can be seen on the message screen below. If the code is correct, we can upload it to our Arduino hardware board. For this, we will first connect the Arduino board to the USB port of our computer. Now we will go to the Tools menu and select Arduino Uno. Then, we will go to the port option and select the port at which Arduino is connected. Now, to transfer this code to our hardware, we will press this arrow button. Our code has been uploaded to the hardware successfully. Now we will assemble our hardware. Connect a red, black, purple, orange, green, yellow, and brown wire at VCC, ground, RST, MISO, MOSI, SCK, and SDA pin of RFID reader RC522. Now connect red wire with 3.3 volt pin, and black wire with ground pin of Arduino. Connect purple, orange, green, yellow, and brown wire with pin number 9, 12, 11, 13, and 9 of Arduino. We will take 3 wires, 1 red, and 2 black. We will use these wires later. Now we will solder a black wire at hole number 1 and red wire at hole number 2 of LCD display. Now we will solder a white wire at hole number 4 and brown wire at hole number 6 of LCD display. Now we will solder orange, yellow, green, and blue wires at pin number 11, 12, 13, and 14 of LCD display. Now connect hole number 16 with hole number 1 using a black wire, and hole number 15 with hole number 2 of LCD display using a red wire. Now connect hole number 5 with hole number 1 of LCD display using a black wire. Now connect hole number 3 with hole number 1 of LCD display through a 1 kilo ohm resistor. Now we will connect the LCD display with Arduino. Connect the red wire with 5 volt pin and black wire with ground pin. Now connect white, brown, orange, yellow, green, and blue wires with pin number 7, 6, 5, 4, 3, and 2 of Arduino respectively. Now we will power up our circuit and test its functionality. We will take 3 RFID tags and read their IDs by scanning them one by one. We can see that RFID reader is reading and displaying the ID of RFID tags on the LCD screen. Our project is working as expected. I hope you enjoyed the video and learned something from it. For any help in your project or to clear your doubts, you can contact us on our student care number 7007957715. To purchase the items used in the video, you can visit our website www.erolltech.com. You can order us on our WhatsApp number also. Thank you so much.